Over the last decade, the growth of satellite service, the rise of digital cable, and the birth of HDTV have all left their mark on the television landscape. Now a new delivery method threatens to shake things up even more powerfully. Internet Protocol Television has arrived, and backed by the deep pockets of telecommunications industry, it's poised to offer more interactivity and bring a hefty dose of competition to the business of selling TV. Welcome to IPTV, Video over Internet Protocol. Hello, and welcome to my presentation, Video over Internet Protocol. My name is Giovanni Alvarez, and I will be presenting you information about Video over Internet Protocol and how it has impacted our today's telecommunication industry. I will speak with you in regards to general concepts, server requirements, and the key components for having a successful video streaming infrastructure. I hope you enjoyed this presentation, and thank you for watching. Packaging video with voice and data services provides benefits beyond the cost reduction of using a common infrastructure. New features and capabilities can be implemented through the interaction between three services. Ads customized for the user or region can be inserted into subscriber preferred video content. Incoming voice call information can be delivered on screen, while the video transport capabilities of environment can be leveraged for video telephony. The most popular encoding mechanisms today are MPEG-2 for managed video services, MPEG-4, and H.264 for over-the-top and business services. Hello, and welcome once again. In this session, we'll be talking about the protocols that are used for IP video conferencing and for video streaming within the network. One of the protocols that is used to transport the encoded video content over the IP or over the network is called the UDP, User Datagram Protocol. Another protocol that is used for real-time services is called the RTP, Real-Time Transport Protocol. Also, there are protocols that transport single programs through the network, which is called the SPTS, Single Program Transport Stream. And there's another protocol that is called for multiple programs, so it can be multiplexed and transported over the IP, called the MPTS, the Multiple Program Transport Stream. Now, for video conferencing, it is very important that the video is delivered to the other side, to the other user, in a high quality of video service. One of the protocol that is used to deliver this quality is the H.323. This protocol is used to perform call control for multimedia communication on packet networks. Another protocol that is used to establish, modify, and terminate multimedia session is called the SIP Session Initiation Protocol. All these protocols are very essential and very important to deliver a high quality video to the user services. Thank you very much, and we'll see you shortly. Key components for video over IP architecture. Hello, and welcome once again. In this session, we'll be talking about key components of the video over IP architecture that makes it very important to provide excellent quality video pictures for the customer and subscriber homes. One of the components that we'll discuss is called the Superhead End, SHE. Live video feeds and real-time encoding of video broadcasts typically originate from one or two SHEs, where asset distribution systems are also located for on-demand services, along with back-end systems. The second component is the Video Hub Office, the VHO. Operators typically maintain a few dozen regional VHOs, usually in the metropolitan areas, serving 100,000 to 500,000 homes. VHOs often contain real-time encoders for local television stations, as well as the network routers that connect the distribution network to the network core. They also typically house most content service used for VHOD services. The last component I would like to talk about is the central office and the video switching office, VSO. Central offices and VSOs house aggregation routers that combine traffic to and from subscriber homes. These components are very important, and we are seeing it today, like the company that are promoting and pushing these products. One of the companies is Verizon Fios Services, and for cable companies, the Triple Play Services. I hope you enjoyed this information, and we'll be back with you shortly. There are important requirements for a very successful video architecture. The implementations of this architecture requires, among other things, a thorough bandwidth budgeting, high capacity, high forwarding performance routers handling both unicast and multicast traffic, fast converging IP unicast routing designed for video on-demand services, a fast converging source specific multicast based design for broadcast video service with special design consideration for channel zapping, and a QoS or quality of service design based on rigorous differentiated services or integrated service. Redundancy and channel are very important because this provides a setup time improvement typically achieved by sending the video content over two different paths to a point as close as possible to the subscriber, and a set of tools and system that facilitates the process of operating and monitoring the services. Thank you, and we'll be back shortly. We have reached the conclusion of a small presentation of video over IP. Video delivery over IP presents multiple business and service opportunities. Its deployment, however, is not a trivial matter. Of the three services in Triple Play, video demands the most from network services, so it greatly affects the design of the video architect. In a well-designed IP network and with the help of appropriate service management tools, several service providers successfully deployed and operate large-scale video over IP services offering HDTV. At an ever-improving viewing experience, over-the-top content providers are reaching the growing internet population, not only as viewers, but also as content producers. And all these services are running over IP. My name is Giovanni Alvarez, and thank you for watching. So long.